This is the second one of chapter 7, which is called similar polygons. So, first two vocab that you need to know are, this is the only two in this chapter, or what a similar polygon is and what a scale factor is. Okay? A similar polygon has corresponding angles that are congruent, that are the same, and corresponding sides that are proportional. So it's two figures that have the exact same angle measures, but their sides are all proportional. They're all multiple of 2, or they're all going up by a multiple of 5, or whatever, kind of just like we saw before. And then the scale factor is that numerical ratio you get when you compare corresponding sides of similar figures. So it's how much bigger, how much scaled up or scaled down is this new figure. So with the similar polygons, again, the angles have to be the same. Oh, we're going to go over an example in just a second. Angles are all the same. Their sides are proportional. Similarity differs from congruence because congruent means they're the exact same. It means all their sides are the same, all the angles are the same. With similarity, all the angles are the same, but the sides are scaled up or scaled down versions of each other. So it's different from congruent. Angles have to be the same, sides are proportional. But the symbol you need to know, the similarity symbol is just that tilde sign. Remember, for congruent we put that on top of the equal sign. But for similarity, this is the symbol we use. So when we say two figures are similar to, this is the figure this is the symbol we put in between them. It's just that squiggly, that tilde symbol. Okay? So similar is just that tilde. In this case, these two figures would be similar because their angles are all the same. This A is congruent to this. We call this A prime with the apostrophe. So I would write it as A, B, C, D is similar to A prime, B prime, C prime, D prime. Okay. Because remember, the order does matter. So angle A matches up with A prime here. The prime is just that apostrophe. That's what we call it.
Do we get apostrophe?
Yes, I will get one. Yes, I will. B is congruent to B prime. C is congruent to C prime. D is congruent to D prime. So all the angles match up. All the angles are the same degrees. Okay? But their sides are proportional. This is the larger figure, right? What's the scale factor of this figure? How much am I multiplying to get from this figure to this figure, each side? It's 2, right? That's the scale factor. The scale factor is 2. To go from this figure to this figure, I'm multiplying each side by 2. 3 times 2 is 6. 2 times 2 is 4. 4 times 4 is 8. 4 times 2. 3.5 times 2 is 7. So that's our scale factor in this problem. You could also look at the scale factor from going from this figure to this figure, right? You're multiplying by a half to go from this figure to this figure, right? Half of 6 is 3. Half of 4 is 2. Half of 8 is 4. Half of 7 is 3.5. So you can look at the scale factor either as going from this figure to this figure, it's a half, or going from this figure to this figure, it's 2. That makes sense? Yeah. Yep. So looking at these figures, I just want to know, are these similar or not? Are these two triangles similar? Is one a bigger version of the other with the same angles? Are their sides proportional? Okay. Just by looking at these, would you say these are similar or not? Is one a bigger version of the other, where their angles match up? Okay. That vertex angle, the angle between those two congruent sides, are different. So their angles already aren't congruent, right? So these are not similar because we know their angles have to be the exact same. Angles have to be the exact same, sides are proportional. So in this case, we would say these two figures are not similar because their angles, in this case the vertex angle, the side between there, is not congruent. I'm going to erase this here a second. I want to know, are these two triangles similar? Okay. Are they similar? So I first want to check and see if their angles are all congruent, because the angles have to be congruent, the sides have to be proportional. So I have angle 80 here, that matches up with angle 80 there. 60 here, I need to know if this angle is 60. Okay. Well, this is a triangle. 3 angles of a triangle up to 180. 80 plus 40 is 120. So that means there are 60 degrees left over for that one. So I know those angles match up, those angles match up. Then I need to know if both of these are 40. Well, three angles of a triangle are 180. 80 plus 60 is 140. It means there's 40 degrees left over. Excuse me. So I know those angles match up. So it's past the first part of the definition of similarity. Again, to be similar, all the angles have to be the same and all the sides have to be the same proportion. But now looking at the sides, I can't tell automatically they're all going up by multiples of 2, right? Like the one before it said they're all going up 2 times. It was really easy. So I need to check the ratios of each of these sides. For example, this side should match up with which one of the other one? It would be SRRS, right? Those would be the sides I want to be proportional. Okay, so I'm going to check that ratio. What about this side? BC should be proportional to ST, and AC should be proportional to RT. So I'm going to check those 3 proportions to see if they're all the same, or those 3 ratios to see if they're proportional. I'm going to check these 3 ratios. It doesn't matter if I start with this one or if I start with this one. I just need to keep it consistent. So I'm going to check, is 5.2 to 3.9, what is that ratio? I'm going to check 7 to 5.25, and I'm going to check 8 to 6. Everybody see how I did that? I always started with this triangle. So I'm going to check the ratio of those sides. I'm going to check the ratio of the red sides. I'm going to check the ratio of the yellow sides. And if all of these are the same, I know it's similar. If any of them are different, they're not similar because the sides aren't proportional. Okay. So a really easy way to do it is just punch this into my calculator. Do 5.2 divided by 3.9. Do 7 divided by 5.25. Do 8 divided by 6. Okay. I think it's 1.3 repeating, and it happens to be that for all of them. So all the ratios are the same. All the ratios are the same. So are these 2 figures similar? They would be, because their angles are congruent and their sides are the same ratio. So I would write it out as triangle ABC is similar to triangle RST. That's what that would look like. This number would be my scale factor. To get from this triangle to this one, you have to multiply each side by 1.3. If I multiply 3.9 by 1.3, I get 5.2. Multiply that by 1.3, I get 7. Multiply that by 1.3, I get 8. Okay. Scale factor, similar. To be similar, all the angles had to be the same and the sides had to be the same ratio. I tell you that these 2 trapezoids are similar. What is their similarity statement? Meaning which of these is the correct order to say that these 2 triangles are similar. So this is a bigger version of this one. Okay. So they all start with TRAP. So going in that order with TRAP, it would obviously be here ZOLD, right? So this would be our similarity statement. This angle matches up with this one, this with this one, this with this one, and this with this one. Now here the 2 polygons are similar. Solve for A. Here's where our proportions come in. So this is a bigger version of this figure here. I want to solve for A. Okay. So I know that this side would be proportional to which side of the other one? ZO, right? Those would be proportional. I know this side would be proportional to this side. And I know this side would be proportional to that side. I want to know what A is. Meaning to get from 3 to 5, I have to do the same thing as to get from A to 4. Okay. So I'm going to write a proportion. There's a bunch of different ways you could do this, but I'm going to say 5 to 3 should be the same as 4 to A. Again, this side compared to this side should be the same as this side compared to this side. They should be the same ratio. Okay. If I would have did it the other way, I could do it the same way. 3 to 5 is the same as A to 4, right? This side compared to this side should be the same as this one compared to this one. Both of these things are going to give me the same cross product, right? If I cross multiply here, I'm going to get the same thing. I'm going to get 12 is equal to 5A. No matter which way I did it, 12 is equal to 5A. Divide both sides by 5. So I get A is 2.4. Okay. So I'm just comparing sides. This side to this side will be the same as this side to this side. Why didn't I use the yellow side instead? I had to use the red side because I wanted A. Why did I use the blue side instead of the yellow side? Because I had another variable up here, right? I would have had two variables in my cross multiplication problem, and I couldn't have solved it then.
You can still do that, right?
It would work. It's correct, but I wouldn't have been able to solve for A because I would have had B on one side and A on the other.
Are we gonna have like one of those like where we have to do that?
No, you have to have. If you did, you had to have two different proportions. In this case, I used these two sides because I both had numbers. I didn't have any variables. I'll give you a second to try this one. Same two figures. I want you to solve for B here, though. So again, you know they're similar. You know this one is a bigger version of this one. It's being blown up by the same amount. Okay. So all I have to do is compare the sides to solve for B. So I know that this side and that side are proportional. Those are the sides that would match up, right? Those are the corresponding sides. So you can either start with 2 over B minus 6 or B minus 6 over 2. It doesn't matter which way you start with. Okay. So I'm going to say, I'm going to go from the big trapezoid to the smaller one. It doesn't matter though either way. 2 over B minus 6. That means since I started with the big trapezoid here, I need to start with the big trapezoid in my other part. Okay. Now, is the side I'm going to compare it to, based on this problem, this side or this side? I would pick this one. Even though we knew what A was from the previous problem, I would go ahead and pick this one because we know that's 3 and 5. So the question is it going to be 5 over 3 or 3 over 5 here? It's got to be 5 over 3 because I started with 2 here, so I need to start with 5 here. So it's proportional to 5 over 3. And then we solve this just like we did at the beginning of class. We're going to cross multiply. Doesn't matter which way you start with. 3 times 2 is 6. Remember, when you cross multiply here, you need to take 5 times all of this B minus 6. So it's 5 times B minus 6. So then you'll go ahead and distribute that 5 to get 5B minus 30. You'll add that 30 to both sides to get 36 equals 5B. And then you will divide both sides by 5. So you will get 36 over 5 equals B, which that simplifies to 7.2. B would be 7.2 if I wanted to find what this side is. Okay, it would be 1.2 because I'd have to subtract 6. Does that make sense what similarity is? We're going to continue talking about similarity this entire chapter. Okay. But you can just think of it being blown up or scaled down versions of each other to figure. Angles are the same, sides are proportional. Same figure, I want to know what is the scale factor. Okay. Meaning to go from one figure to the other, how much are you multiplying by? Well, again, we just compared it. It's either 5/3 or 3/5, right? If you compare these two sides. So I would accept either of those answers. Because that's how I get from one figure to the other. It's 3 over 5. I would set that equal to the other side, or set that equal to the other side. So this number, this comparison, this ratio is our scale factor.